In the preceding, I believe I failed to put absolute value signs around this result. So I'm going to have some redundant signs of grouping, but let's go ahead and put absolute value signs around this. Now, if we multiply through the numerator and denominator by this denominator, square root of pi squared a squared plus 4t squared, and the motivation for doing that, of course, is we don't want any numerators in our numerator. So we go ahead and multiply through the numerator by this square root, and we'll also multiply through the denominator by the square root. Multiplying this denominator by that square root is going to give us a fourth power of the square root. The 3/2 power is the cube of the square root. Another one is going to give us a fourth power of the square root, and that's how I wrote it. I could as well have written it without the square root and a 2 here, and we'll do that in the next step. We'll note that I didn't include this in either case inside of the absolute value. This is a factor of the entire expression, so I can actually factor it out, and it's always positive, so it's not going to contradict the fact that we're doing an absolute value. Okay, multiplying numerator and denominator through by the pi squared a squared plus 4t squared, the square root of the quantity I just said, is basically going to make this square root and this square root and this square root sign go away. So we're writing down these same three terms here, but without the square root, and I've multiplied the 2 by the 2 to get the 4 on the k component. Otherwise, the expressions are pretty much as you see them without the square root. Now these terms here are going to just go right on through, except that the denominator is just going to go away. And I've written it out in the same order in which it appears here: pi a times 4t times the sine of pi t, negative pi a times 4t times the cosine of pi t, and of course I've collected this one. Negative 2t times 4t is 8t squared, and that's going to contribute to the k component. So we have our expression for the curvature function. Now, as I believe we've said, the original function, original R of t function, just represents, without the k component, motion around a circle. With the k component, the t squared brings us up in the z direction at an increasing rate. So our first circuit around the circle is going to remain relatively close to the xy plane. Our second circuit is going to take us up 4 times as far as the first one did. They're going to take us to a height that's 4 times as far because, of course, when you square a number that's twice as big, you get a number that's 4 times as big. And that's going to give us a behavior where, for small t, we're going to be pretty close to just the I and j components. For large t, the curve is going to straighten out quite a bit. We're going to have a lot of distance between the coils of what is effectively a helix, but with the coils further and further apart. So we want to analyze what this function is going to give us for small t and what it's going to give us for large t. And we'll look at that in the next clip.